Hey everyone, I hope you're doing well. In this video, we're going to practice finding derivatives using the product rule. Pause to check out the timestamps and feel free to jump around the video by using them in the description. While the notation here can oftentimes be a little confusing, putting it into words can oftentimes be a little bit easier to understand. When finding the derivative of a product, which means just two functions multiplied together, you multiply the first function by the derivative of the second function, then multiply the derivative of the first function by the second function. Once you add those two products together, you'll have the derivative of the entire function. Here's an example of a function that we would use the product rule for finding the derivative. X squared would be considered our first function, or f of x, and this 3x plus 2 would be considered our second function, or our g of x. This is our first function. This represents the derivative of the second function. This will be the derivative of the first function, and this is the second function. Our f of x is x squared, and our derivative, or dy dx, of x squared is going to equal 2x. Our g of x is equal to 3x plus 2, and our derivative of g of x is equal to 3. This is what we get when we substitute our values in. Multiplying x squared by 3, we get 3x squared, and distributing the 2x to 3x plus 2, we get 6x squared plus 4x. And finally, we can combine this 3x squared and 6x squared to get 9x squared. This would represent our derivative. First, start by labeling your first and second function, and finding the derivatives of them on their own. Once you have these four pieces, you can just plug them into the product rule to find your final derivative. Now that we've gone over a little bit of a background, let's go over some different types of examples and do some math together. Let's try example 1 here. In example 1, we have our function h of x. To keep things organized to use our product rule, let's separate h of x into two different functions. We'll call this part our f of x, and this part our g of x. Now that we've identified the two functions we're going to be using, let's write them individually and their derivatives too. We already know that f of x is equal to x to the 8th power plus 2x minus 3. Using the power rule, we can find the derivative of it, or f prime of x, which is going to be 8x to the 7th power plus 2. For g of x, we can say that original function is just e to the x power, and its derivative, or g prime of x, is also equal to e to the x power. These are the four pieces we're going to need to use the product rule. The derivative of h of x, or h prime of x, is going to be equal to f of x multiplied by g prime of x added to f prime of x multiplied by g of x. Remember, if we call f of x our first function and g of x our second function, we're multiplying the first function by the derivative of the second, and adding that to the derivative of the first one multiplied by the second. Let's substitute in now. F of x is x to the 8th power plus 2x minus 3. G prime of x is e to the x power plus f prime of x is 8x to the 7th power plus 2. And g of x is e to the x power. Here's our f and our f prime, and here's our g and our g prime. Since both of these terms have e to the x power, we can factor it out. Factoring out our e to the x power, we'll have e to the x power multiplied by x to the 8th power plus 2x minus 3 plus 8x to the 7th power plus 2. This was the e to the x that was factored out, and these were the other factors. Combining like terms, e to the x power multiplied by x to the 8th power plus 8x to the 7th power plus 2x minus 1. And this is going to be our derivative. Let's try example 2 here. H of x is made up of the product of two functions. We can call these f of x and g of x. You can also still think of them as your first and second function. First, we can write that f of x is just equal to x to the 3rd power. F prime of x, or its derivative, using the power rule, is going to be 3x to the 2nd power. G of x we know is equal to 2x squared plus 1. And g prime of x using the product rule and the sum rule is going to be 4x. Now that we have the four pieces we need for the product rule, let's substitute each of these four pieces into our function. F of x is equal to x cubed, so we'll write that first. And we're going to multiply that by g prime of x, which is equal to 4x. Then we're going to add f prime of x, which is going to be 3x squared, multiplied by g of x, which is 2x squared plus 1. Here's f and f prime of x. And here's g and g prime of x. Multiplying x cubed and 4x together, we're going to get 4x to the 4th power. And from distributing this 3x squared, we're going to get positive 6x to the fourth power plus 3x to the second power. Combining like terms, we can say h prime of x, or our derivative of h of x, is going to be 10x to the fourth power plus 3x squared. This is our answer. Let's try number 3 here. Right away, we should try to separate it into a product of two functions. I'm going to call this first one f of x, and call the second one g of x. Let's write the 4 pieces of information that we need to know. First, we have f of x, which is just equal to negative 3 plus x to the negative third power. From that, we can write f prime of x is equal to negative 3x to the negative fourth power by using the power rule. Copying down g of x, that's just going to be negative 4x to the third power plus 3. And using the power rule, g prime of x is going to be equal to negative 12x to the second power. This will be our first function, and this will be our second function. Just like in the last two examples, now we're going to plug in our 4 pieces into the product rule. F of x is negative 3 plus x to the negative third power. G prime of x is negative 12x to the second power. F prime of x is going to be negative 3x to the negative fourth power. And multiply that by g of x, which is negative 4x to the third power plus 3. Here are the 4 pieces we just substituted in. Distributing here, we're going to get 36x to the second power minus 12x to the negative first power. And distributing over here, we'll get plus 12x to the negative first power minus 9x to the negative fourth power. Since these are opposites, they're going to cancel out. So we'll be left with 36x to the second power minus 9 over x to the positive fourth power. To rewrite this whole thing as one fraction, we could take this 36x squared and multiply it by x to the fourth power over x to the fourth power. In doing so, we'll get an LCD of x to the fourth power. We're going to get 36x to the sixth power minus 9 all over x to the fourth power. This is our derivative of h of x. Now let's try example 4, which includes a trig function. I'm going to call this our f of x. Let's write down the key bits of information that we need to know. First, we need to know f of x, and that's just equal to sine of x. F prime of x is going to equal cosine of x, which is the derivative of sine of x. G of x we know is equal to x cubed plus x. And using the power rule, we can say g prime of x is equal to 3x squared plus 1. Now we're going to plug in our 4 pieces into the product rule. First, we have f of x, which is sine of x, multiplied by g prime of x, which is going to be 3x squared plus 1, plus f prime of x, which is cosine of x, multiplied by g of x, which is x cubed plus x. Here's f and f prime, and here's g and g prime. Since we can't really simplify this anymore, we can say that this is our derivative. For our last example, let's take a look at a function that has 3 parts. I'm going to call this first one f of x, the second one g of x, and a third one r of x. To use the product rule with 3 functions, we're going to write the derivative of the first function multiplied by the second function multiplied by the third function plus f of x times the derivative of the second function times r of x plus f of x times g of x times the derivative of r of x. Notice how in each of the 3 parts we're multiplying all 3 functions together? But in the first time we multiply them, we find the derivative of f of x. The second time we find the derivative of g of x. And in the third time we find the derivative of r of x. Let's write down some information that we need to know. We know f of x is equal to sine of x. And the derivative, or f prime of x, is equal to cosine of x. G of x we know is equal to cosine of x. And g prime of x is equal to negative sine of x. R of x is equal to x cubed plus 2. And r prime of x is equal to 3x squared. Let's start with this part. We'll have cosine of x times cosine of x times x cubed plus 2. I just plugged in these 3 pieces in. Multiplying these 2 pieces together, we can say that this is x cubed plus 2 multiplied by cosine squared of x. Let's save this for later. Now let's find out what this middle part is. To do so, we're going to plug in these three pieces. First, we have sine of x times negative sine of x times x cubed plus 2. Multiplying these two parts and factoring out a negative, we can say this is equal to negative x cubed plus 2 times sine squared of x. Let's hold on to this for a little bit later. Now let's substitute in for this third part. Plugging these three pieces in, we're going to get sine of x times cosine of x times 3x squared. Well, it doesn't really matter. I'm just going to rewrite mine in this order. I'm going to write 3x squared times sine of x times cosine of x. And that's the last piece. Putting these three pieces together, we can say our derivative, or h prime of x, is equal to the quantity of x cubed plus 2 times cosine squared of x minus the quantity of x cubed plus 2 times sine squared of x plus 3x squared times sine of x times cosine of x. While it's quite long, this is the derivative of h of x. That wraps up this video on the product rule. I really hope this video helped you understand the product rule just a little bit better. If you like the video and want to make any comments, please do so in the comment section below. Keep up the good work, and I'll see you in the next one.